A very warm welcome to today's session. I am Rashmi, Assistant Professor, Department of Physics. In this session, let us learn about magnetic dipoles and magnetic dipole moment. Since you are already familiar with electric dipoles, let us first learn about electric dipoles and then we learn about magnetic dipole by comparing it with electric dipoles. Electric dipoles andre enu? As the name itself indicate dipoles anta helidre there are two poles. Electrostatics alli poles anta helidre those are charges. So what does the definition of electric dipole say? It is a system consisting of two equal and opposite charges separated by a small distance. Usually the separation is taken to be 2L. Yake 2L? Because the distance is always measured from the center of the dipole. Each charge will be at a distance small l from the center. Hagagi the total distance between the charges will be 2L and that is the separation between the dipoles. Since these two are charges, any electric charge will produce electric field. What will be the direction of electric field? It will be the electric field will be diverging from the positive charge and it will be converging at the negative charge. Since it is a system, we see that the electric field starts from the positive charge and ends at the negative charge, and I can write the direction of the electric field produced by the dipole in this particular direction. It is very interesting to note that every dipole will be characterized by a property called as electric dipole moment. So it will be a vector. Electric dipole moment is a property which characterizes the dipole, and in order to measure it, we consider it has to be a product of magnitude of charge and the distance between the charge ಅಂತ ಹೇಳಿದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ ಮೊಮೆಂಟ್ ಅನ್ನೋದು ಒಂದು ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ನ ಕ್ಯಾರೆಕ್ಟರೈಸ್ ಮಾಡುವಂಥ ಒಂದು ಪ್ರಾಪರ್ಟಿ. ಅದನ್ನು ನಾವು ಮೆಷರ್ ಮಾಡಬೇಕಾದ್ರೆ we have to take the product of magnitude of one of the charge. So these are two charges of equal magnitude. I need to take only the magnitude. So the magnitude will be Q and the distance between the two charge, which is 2L. So if you multiply the two factor, whatever number I am going to get, that will be called as the electric dipole moment. And this dipole moment is actually a vector and the direction will be from negative charge towards the positive charge. So the direction of dipole moment P is from negative charge towards positive charge. And interestingly, in this particular case, it is opposite to the direction of electric field. Illi ನಾವು ನೋಡ್ತಿರೋ electric field is the field that is created by the dipole itself. So it is actually opposite to the field. ಯಾಕಂತ ಹೇಳಿದ್ರೆ electric field ಯಾವಾಗಲೂ it will start from the positive charge and it will end at the negative charge, or it will be diverging from the positive charge. ಹಾಗಾಗಿ ಸೆಂಟರ್ ಅಲ್ಲಿ ನಾವು ನೋಡಬೇಕಾದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ಗೆ ನಾವು ನೋಡ್ತಿರುವಂತ ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ ಮೊಮೆಂಟ್ ಏನಾಗಿರುತ್ತೆ, ಆಪೋಸಿಟ್ ಆಗಿರುತ್ತೆ. ಸೊ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದಿ dipole moment will be from negative charge towards the positive charge. ಈ ಕೇಸಲ್ಲಿ charge is a scalar quantity, but here I can take that L, the distance, as the vector quantity because I can take it as a displacement. ಹಾಗಾಗಿ it will be written as Q into 2L. Okay. Okay, now let us see what's a magnetic dipole. So as the name itself indicate, it is a dipole. That means it has two pole. So magnets alli two poles anta heladre, one has to be the north pole, another one has to be the south pole, and the strength of the pole is given by plus qm, or you can also write it as m. In some books they use plus qm. Most of the textbook take it as m. So here I have taken it as qm just to compare it with the electric dipole. Otherwise we also use the um, notation of small m. Okay. So when I say magnetic dipole, it is a system consisting of two magnetic poles which are having same strength, pole strength, but of opposite polarity. So if one is plus m, the other pole should have a strength which is minus m, and they are separated by a small distance, and the distance is taken to be 2l. ಇದು ಒಂದು magnet ಆಗಿರೋದ್ರಿಂದ definitely it will produce a magnetic field. What will be the direction of magnetic field? We know that magnetic field diverges from the north pole and converges at the south pole, or magnetic field starts from the north pole and ends at the south pole. Now I can write the direction of magnetic field like this. And just like electric dipole, every magnetic dipole will have a special property which characterizes the dipole, and that is called as the dipole moment, which is represented as capital M in this particular case. So capital M is called as the magnetic dipole moment. It is a property which characterizes the magnetic dipole, and mathematically it is given by the product of the pole strength and the distance between the pole. So since the pole strength I am taking it as qm, I should take the magnitude of the pole strength, so which is qm, and the distance between the pole is 2l. So 2l is nothing but the magnetic length. Uh, the pole, the distance between the pole is also called as the pole length. So either you can write this formula, or in most of the textbook they use the notation m. So we can write it as m into 2l, where small m is the strength of the pole, or pole strength. Okay. And capital M is nothing but the magnetic dipole moment. And this magnetic dipole moment is also a vector, and the direction of the magnetic dipole moment is from the south to north pole of a magnet. And in this particular case, again we can take the length as the vector quantity, and this is how we represent magnetic dipole moment. ಈಗ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಡೈಪೋಲ್ ಅಂತ ಹೇಳಿದ್ರೆ, ಇಸ್ ಇಟ್ ಓನ್ಲಿ ದ ಪರ್ಮನೆಂಟ್ ಮ್ಯಾಗ್ನೆಟ್ ಲೈಕ್ ವಾಟ್ ವಿ ಹ್ಯಾವ್ ಟೇಕನ್ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಮಾತ್ರ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಡೈಪೋಲ ಅಂತ ಹೇಳಿದ್ರೆ ಡೆಫಿನೆಟ್ಲಿ ನೋ, because we know that any current carrying conductor produces magnetic field around it. So if I say this is a conductor which is carrying a current I, that will produce magnetic field in the form of concentric circle. In order to find out the direction of the magnetic field, we use the right hand thumb rule. So if you look at the direction of the fingers are curled in this particular direction. Hagagi, the direction will be like this. So the direction of the magnetic field will be like this. It is going into from the right side, and it is coming out from the other side, which is represented by a dot. But ಈ ಕೇಸ್ ನ ನೋಡಿದಾಗ there is no north pole and south pole because the magnetic field is forming continuous loop. ಸೊ ಇಲ್ಲಿ ಕಂಟಿನ್ಯೂಸ್ ಲೂಪ್ ಇರೋದ್ರಿಂದ ಯಾವುದು ನಾರ್ತ್ ಪೋಲ್ ಯಾವುದು ಸೌತ್ ಪೋಲ್ ಅಂತ ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ. ಬಟ್ if you bend this particular current carrying wire into a loop, ಆಗೇನಾಗತ್ತೆ, now if you are watching the loop from this particular direction, ನಿಮಗೆ ಕರೆಂಟು ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಹೋಗೋ ತರ ಕಾಣ್ತಾ ಇರುತ್ತೆ. if there is an observer who is observing the loop from this particular direction, to him he'll observe the current to be moving in a anti-clockwise direction. And how will be the magnetic field that is generated? For that we should use the right hand thumb rule. So if you look at the right side of the loop, the current is going upward, and using the right hand thumb rule I can say the magnetic field actually comes out from the right side. What about the left side of the loop? In the left side the current is actually going downwards, and again if you use the right hand thumb rule, you will again observe the current is also coming out of the loop. So at every point the magnetic field is actually coming out of the loop. So it is coming out of this particular surface and it is turning back here, and from the back surface of the loop it is entering the loop. Okay, so for a person who is looking at the loop from this particular direction, he observes the magnetic field is actually coming outward. And if there is an observer who is watching at this loop from the backside of the loop, to him the loop looks to be carrying a current in the clockwise direction, and he'll observe that the magnetic field is entering the loop. Okay, so now we can easily recognize that one side of the loop is behaving like a north pole because the field lines are coming out of it. The other side of the loop is actually behaving like a south pole because all the field lines are entering into it. If we compare this magnetic field direction, so this is the direction of the magnetic field. So we can say the magnetic field is coming out of this loop. So this side is acting like a north pole and the other side is acting like a south pole because magnetic field is entering from this side. ಹಾಗಾಗಿ ಒಂದು ಕರೆಂಟ್ ಲೂಪ್ ಇಲ್ಲಿ ಯಾವ ತರ ಬಿಹೇವ್ ಮಾಡ್ತಾ ಇದೆ, ಒಂದು ಸ್ಮಾಲ್ ಟೈನಿ ಮ್ಯಾಗ್ನೆಟ್ ತರ ಬಿಹೇವ್ ಮಾಡ್ತಾ ಇದೆ. ಸೊ ಇಫ್ ವಿ ಕಂಪೇರ್ ಇಟ್ ವಿತ್ ದ ಪರ್ಮನೆಂಟ್ ಮ್ಯಾಗ್ನೆಟ್ ಲೈಕ್ ಅ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್, ಇಲ್ಲಿ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುವಂತ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ನ ನಾವು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ಅಗೇನ್ ಇಟ್ ಇಸ್ ಸಿಮಿಲರ್ ಟು ದಟ್ ವಿಚ್ ಇಸ್ ಕ್ರಿಯೇಟೆಡ್ ಬೈ ಅ ಕರೆಂಟ್ ಲೂಪ್. ಸೊ ಕರೆಂಟ್ ಲೂಪ್ ಇಂದ ಬರುವಂತ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಇಂದ ಬರುವಂತ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಸಿಮಿಲರ್ ಆಗಿದೆ. ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಇಸ್ ಬಿಹೇವಿಂಗ್ ಲೈಕ್ ಅ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಡೈಪೋಲ್ ಅಂತ ಈಗ ತಾನೇ ನೋಡಿದ್ವಿ, and it has two poles. So one is the north pole, another one is the south pole, and it is separated by a small distance. So it is acting like a magnetic dipole, and the magnetic dipole moment is given by what? M, which is equal to the strength of the magnetic pole, which is taken as M, and the distance between the two poles is taken as 2L. What about the dipole moment of a current loop? Just now I said the current loop is producing a magnetic field similar to a bar magnet. That means current loop is also behaving like a bar magnet, or it is behaving like a magnetic dipole. So when the magnetic dipole ide andmele, by the definition it should have a property called magnetic dipole moment. ಆದರೆ ಈ ಕೇಸಲ್ಲಿ what is the strength of the pole? Here we don't see any pole or the distance between the pole ನಮಗೆ ಗೊತ್ತಾಗಲ್ಲ. Then how to define the magnetic dipole moment of a current loop? So in case of a current loop, the magnetic dipole moment was, was found to be proportional to the current that is flowing into the inside the loop. ಈ ಒಂದು ಲೂಪ್ ಅಲ್ಲಿ ಎಷ್ಟು ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಿದೆಯೋ ಅದ್ರ ಮೇಲೆ ಅದರ ಡೈಪೋಲ್ ಮೊಮೆಂಟ್ ಡಿಪೆಂಡ್ ಆಗ್ತಿದೆ ಅಂತ ಗೊತ್ತಾಯ್ತು. And it was also observed that the magnetic dipole moment was proportional to the area of this loop. So it was proportional to A, where A is the area of loop. So if you take a larger loop, the magnetic dipole moment used to increase. So using these two information, I can write the formula for magnetic dipole moment of a current loop to be equal to current into the area of the loop. So the SI unit of the magnetic dipole moment will be, current na SI unit is ampere, area du SI unit bandu meter square, so it is going to become ampere meter square. And also, because I am talking about dipole moment is a vector quantity. So if I write the vector notation, we know current is a scalar quantity, but in physics, area is taken as a vector quantity. So we take it as area vector. So dipole moment is a vector which is given by current into area. Since we know the magnitude of the dipole moment, now let us talk about the direction of the magnetic dipole moment, because it is a vector. So what will be the direction of this vector? In order to find out the direction, we use right hand corkscrew rule. So what does the rule say? If you place the screw near the surface of this coil, and if you start rotating the screw in the direction of the flow of current, in whichever direction the screw moves gives you the direction of the magnetic dipole moment. ಅಂತ ಹೇಳಿದ್ರೆ ಒಂದು ಸ್ಕ್ರೂನ ತಗೊಂಡು ಈ ಲೂಪ್ ಹತ್ರ ಇಡೋಣ. ಆ ಸ್ಕ್ರೂನ ನಾವು ಇನ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಕರೆಂಟ್ ಫ್ಲೋ ತಿರುಗಿಸ್ತಾ ಹೋಗೋಣ. ಆ ತಿರುಗಿಸ್ಬೇಕಾದ್ರೆ ಆ ಸ್ಕ್ರೂ ಯಾವ ಕಡೆಗೆ ಮೂವ್ ಆಗುತ್ತೋ that will give you the direction of the magnetic dipole moment. So in this particular case, the screw is going to come out. Therefore, the magnetic dipole moment will be in this particular direction. Even otherwise, ನಮಗೆ magnetic dipole moment ನ define ಮಾಡಬೇಕಾದ್ರೇನೆ ಹೇಳಿದ್ವಿ, the dipole will be facing towards the north pole. So it will be from the south pole towards the north pole. ಈ ಲೂಪ್ ನ ನಾವು ನೋಡಿದ್ರೆ magnetic field line is coming outside this particular side. Therefore, this is behaving like a north pole, and the field line is entering this side. So this side is behaving like a south pole. The magnetic dipole moment in this case should be from south to north. If I can generalize this and say, for an observer who is observing the loop, if he finds the current is flowing in anti-clockwise direction, so ಒಬ್ಬ ಅಬ್ಸರ್ವರಿಗೆ ನೋಡ್ತಿರುವಂಥ ಲೂಪಲ್ಲಿ ಆಂಟಿ ಕ್ಲಾಕ್ವೈಸ್ ಡೈರೆಕ್ಷನಲ್ಲಿ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಿದೆ ಅಂತ ಅನ್ಸಿದ್ರೆ, this particular loop will be behaving like a north pole. So the magnetic field lines will be coming out, and this particular side of the loop will be behaving like a north pole. If an observer observes that the current flowing in the loop is in the clockwise direction, in that case, this side of the loop will be behaving like a south pole. So if the current is in clockwise direction, ಆಗ ಅದರಲ್ಲಿಂದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಒಳಗೆ ಹೋಗ್ತಾ ಇರತ್ತೆ. ಸೊ ಇನ್ ದಿಸ್ ಕೇಸ್ ದ ಲೂಪ್ ವಿಲ್ ಬಿ ಬಿಹೇವಿಂಗ್ ಲೈಕ್ ಅ ಸೌತ್ ಪೋಲ್. ನಾವಿಲ್ಲಿ ಏನನ್ನ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಂದ್ರೆ, ಕರೆಂಟ್ ಲೂಪು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಡೈಪೋಲ್ ತರ ಬಿಹೇವ್ ಮಾಡಿದ್ರೂ ಕೂಡ ಅಲ್ಲಿ ಯಾವುದೇ ಟ್ರೂ ನಾರ್ತ್ ಪೋಲ್ ಅಥವಾ ಸೌತ್ ಪೋಲ್ ಅಂತ ಸಪರೇಟ್ ಇಲ್ಲ. ಅಲ್ಲಿ ಒಂದೇ ಒಂದು ಲೂಪ್ ಇದೆ, and it has two phases. one phase will be acting like a north pole and the other phase will be acting like the south pole. So that is the direction of magnetic dipole moment in case of a current loop. Now let us talk about the SI unit. Magnetic dipole moment na SI unit ಏನಾಗಿರುತ್ತೆ? So obviously it is given by current into area. The SI unit for current is ampere. And what about area? Area is measured in meter square. So the SI unit for the magnetic dipole moment will be area into meter square. Okay. So that is about the magnetic dipole moment produced by a current loop. Hope you have enjoyed this session. Thank you.